right. So now we will be solving structured questions, paper 2 for dynamics. There might be some other questions from other topics like definitions or reasoning. So just accept them, please. So first question is work done. We will study this later in another chapter, but I can just tell you the work done is a product of force and displacement in the direction
Do we take energy?
of force. This is the only definition. There is no other definition. So please don't ask anything other than that is wrong. Product of force and displacement in the direction of force is called work done. Kinetic energy is energy possessed by an object, or you can say possessed by a mass due to its speed, you can say, or due to its motion, you can say. So energy possessed by an object due to its motion is called kinetic energy. A leisure park ride consists of carriage that moves along the railed track. Part of the track lies in vertical plane that follows an arc xy of the circle with radius with radius 13 meters as shown. The mass of the carriage is 580 kilograms. It has initial velocity 22 at x, and it has a velocity 12 at y. The vertical section is at point y. For the carriage to move from x to y, decrease in kinetic energy. Kinetic energy actual formula is half mv square. Since you want the change or decrease energy, we always do the large value. Large, what is the maximum speed? 22 square minus 12 square. Individual squares you subtract 9.9 10 power 4 joules. Calculate the gain in gravitational potential energy. Delta GPE will be equals to mgh. Mass is 580. G is 9.81. Height, go to the question. If you look, the vertical height from here to here is equals to this radius, which is 13 meters, which is 13 meters. You substitute 14 here, and the answer is which is how much GPE it gained. It depends upon how much height it gained, my dear. Which is calculate the gain in GPE. So it depends upon how much height did you gain. Certainly there could be a friction. Certainly there could be a resistance. Certainly any resistive force. So it may not be loss in kinetic is equals to gain in potential. This is only true if there is no other transfer of energy. This answer is 7.4 into 10 power 4 joules. All right. A student asking me, shouldn't I write loss in kinetic is gain in potential? My answer was no. Why? There might be a frictional force. There might be a resistive. And the question is calculated. Show that the length of the track is this. So length of the track is actually the distance of the curved path, which is a quarter circle. So distance or travel from x to y is actually an arc, which is equals to quarter circle. So quarter circle, the full circle is 2 pi r, which is the circumference. So quarter circle will be 2 pi r over 4, 2 pi 13 over 4, which is rounding to 20 meters. since they ask you show that, so you can take this value. Now, my dear, you were asking me a question that isn't loss in kinetic, gain in potential. My answer to you was that there could be a resistive force. So certainly now I will apply a principle of conservation of energy, that the total loss in kinetic energy should be gain in GPE, but not. Are they equal? So it means there is an energy loss. So first find the energy loss, and then we will solve this question. So actually the energy loss from X to Y is equals to work done against resistance, resistive force. Now, energy loss. How much kinetic you had? 9.910 power 4. Minus how much GPE you got? 7.4 into 10 power 4. So the difference is the energy loss. Difference is the, which is equals to work done. Work done is force times the displacement. Force, yes. The displacement, the distance traveled along the path was 20. Solve it, my dear. Subtract the two values, divide by 20, you get the resistive force. Which is how much? 1,250. Exact? Yes. You can write two, you can write three significant figures. I don't mind. Okay, describe the change in direction of linear momentum as the carriage moves. So the total change in direction is by 90 degree, by or perpendicular. Yes or no? Look at that. Here, actually, they did not say, they say consists of a carriage that moves a rail track lies in a vertical. Yeah. So here momentum was horizontal. Here momentum was, and here momentum is now exactly vertical. So changes from horizontal to vertical or changes direction by 90 degree. Either you can say momentum changes from horizontal to vertical. Those who want to write, yani changes direction by 90 degree. By 90 degrees. Certainly, I will prefer the first answer. It's more clear from horizontal to vertical. Determine the change in momentum. Now, this question is really beautiful question. Now, initially, you had horizontal momentum, yes? Eventually, you have what? Vertical momentum. Change is difference. Difference means Py minus Px, but they are at 90 degree. Okay. If you make up, you are right, Pythagoras theorem. So Py will be as it is. Py will be as it is. You want to subtract Px. Px direction will be changed. Yes? So the change in momentum is this one. So I heard someone saying Pythagoras theorem. Very good. Whenever two vectors are at 90 degree, their addition or subtraction follows the Pythagoras theorem. So find Px, my dear, find Py. Okay, mass was 580 and 22 and 12. 580 times 22. 580 times 12. Horizontal component of momentum was, please make calculations. 127, 0. 12,760. Okay, and vertical 6,960. So change in momentum, Px square plus Py square square root. I am not subtracting. They are not in same direction or opposite directions. 90 degrees. So 12,760 square plus 6,960 square root, which is 1453 0.34. So 1.5 into 10 power 4 Newton second. It's really a genuine question. So change in momentum, whenever any two vectors at 90 degrees, you only have to apply Pythagoras theorem to get the resultant, whether it's addition or subtraction of the two vectors. The best. Next, my dear. Question number 2. Okay, this question is a familiar question to all of you, I'm sure. It's a very good question. Professor Dr. Hani Yasser, Professor Dr. Abbas Ahmed, and Professor Dr. Ahmed Abbas, they did it correct. So balls X and Y, they are moving along horizontal frictionless surface, and X has a speed of 3 meters per second, Y mass 2.5 and speed is 9.6 meters per second. The angle is 60 degrees between them. After collision, they both move in direction perpendicular to AB by considering the, now here is the hint, components of momentum in the direction of AB. AB, AB, bus, X components. So my dear students, although I want only AB, I will still resolute complete in both cases. For the next part. Dear students, X direction is already there. So this has two components. One is the left side, which is 2.5, 9.6. This angle 60, so this angle is also 60, cosine 60. It has upward direction 2.5, 9.6, sine 60. I resolute it. Okay, now in X direction, I highlighted green color for you. So we say Tumbuk is equals to Mach. Total momentum before collision, total momentum, okay, X directions, right? X directions before collision, okay, the X, mass of X, they did not say, so you say M, okay? Can I say M? So M times 3 plus negative 2.5, 9.6 cosine 60. You should know why did I use negative sign? Because the X was to the right side, so momentum of Y was to the left side, the resoluted component. Yes? All right. Now, after collision, is there anything in X direction? No, 0. So 3M, yes, it is minus 4. No, it's 12. 3M minus 12 is equals to 0. 3M is equals to 12. M is equals to 12 divided by 3, which is 4 kilograms. It was just a simple question. It's clearly mentioned in the question that consider the components in the direction of AB means horizontal components. You got it. Sure. I give you 19.4 seconds to absorb this information. Can you not?
You know.
Wallah, if she does this again, I will kick you out of this class. Wallah, if you say again, I will over him. Okay. Good. Next part. Bible. Good. Calculate the common velocity V. Now, common velocity V is actually the Y component. So now I will take Y components. Y components also the same thing. Tumbuk is equals to Mach. Total momentum before collision in Y direction. Go here. It was only one, which was 2.5 times 9.6 times sine 60. 2.5, 9.6, sine 60. After collision, they move together, X plus Y, their mass. Mass of X is 4. Mass of Y is 2.5. common velocity v. The left side, 6.5? No.
Radical.
The right side is 6.5. The right side is
Radical.
12 radical 3. So 12 radical 3 over 6.5 is v, which comes to be 3.2 meters per second. Next question. Difference in their initial kinetic energy of X and initial kinetic energy of ball Y. Easy. Kinetic energy of X, separate. Kinetic energy of Y, separate. Initial, X was 4. Its initial speed was 3. 18 joules, right? Y, half. 2.5. Initial speed of Y was 9.6. The answer is that's wrong.
How is it?
Oh, you calculate together, huh? 1.2. Okay, you did together, right? So the difference will be 115.2 minus 18, 97.2 joules. All right. Why do I use Y component here? Because the common speed after collision is only the Y direction. Both the X in the part A and Y in the part B. If you use X component here, you already used it. Okay, next question, my dear. Let me read. I think it's FDP, the next chapter. Forces, density, pressure. Can you give me a while, please, just to read this question?
Yes, sir.
A jet of water hits a vertical wall at a right angle with the speed 5 meters per second in horizontal direction. Cross-section area of the jet is 1.5 into 10 power minus 4 meters per meter square. The density of water is 1.0 into 10 power 3. The water runs down the wall. Show that over a time of 1.6, the mass of the water hitting is 1.2 grams, my dears. Excuse me. Oh, bother me. Okay. My dear students, just for your knowledge, like, accept this challenge. So they say over this time, this much mass hits, right? You know, the speed is horizontal speed is constant. So if you say in time 1.6 and at what speed it hits? 5. So it will travel the distance. Yani, how much mass will travel the distance through this specific cross-section area is 5 times 1.6. It will cover 8 meters. Cross-section area is how much? 1.5 into 10 power minus 4. So how much volume will be in this time? Cross-section area times the distance. So volume of the water or whatever was the liquid is area of cross-section times the distance traveled is 12 into 10 power this. So it is 1,200. I don't know. Can you calculate? No, I mean 1.2 into 10 power minus 3, right?
Yeah.
Meter cube. Dear students, we will study this chapter next time just to let you know. Density is mass over volume. So mass is density, which is 1.0 into 10 power 3. Volume is 1.2 into 10 power minus 3. How much, Abbas, you said?
3.2.
Excellent, my dear boys. See, my dear? Excellent. All right. Now, my dear students, calculate the decrease in horizontal momentum. Excuse me. Horizontal momentum, delta px. So decrease is just a change. It has a momentum, then there is no horizontal momentum. So mass is 1.2. Speed was 5. It falls vertically. So there is no more horizontal momentum. 6. Good boy, my dear. The magnitude of horizontal force. Force is change in momentum over time. So 6.0 over 1.6. Which is 3.75.
Yes, sir.
Next question, my dear. Students, actually, I did the math because I can use in the next parts. So what was the idea? We said in a given time how much distance this will travel, and the area we know. It helped us to get volume. Volume and density gave you the mass. Mass gave you change in momentum. Change in momentum gave you the force. State and explain the magnitude of horizontal force exerted on wall by water. Newton's third law of motion says what? Force. This was on water by wall. And this is what? On wall by water. Same. State how much? 3.75 Newton. Yes. So according to Newton's, explain third law, force exerted on wall by water is equal and opposite to force exerted on water by wall. Newton's third law of motion. This question was good, my dear. You were saying part one. Part one is fine from the other chapter, Yani. Calculate the pressure. Pressure is force per unit area. Force you calculated 3.75. What was the area? 1.5 10 power minus 4. Which is no, it hits and falls. No. The area is the same which comes from the pipe or hose, you know, which is sorry, pascals. Question number 4. Please open question number 4. The next page.
Question number?
4. Mashallah. Are you understanding now? Sure. 2 blocks slide directly towards each other along the frictionless horizontal. It's important to mention, my dear. Why? So that it's an isolated system. So you can see their velocities and speeds. Right now, actually, they are momentums they gave you. Momentum of X and momentum of Y you have. Initial and final. So they say after the blocks collide, the block X moved to the left back along the original path with a momentum 0.13. Block Y also moved to the left after collision. Block X has initial kinetic energy of 0.3. Find the mass. Dear students, actually, there are 2 ways to solve. One way is directly, if you know the proof, kinetic energy is what? It was P square over 2M. If you don't know this equation, totally fine. You can do individually. I guess this question is familiar.
Yeah.
Okay, I gave you this proof or no? Yeah. So kinetic energy of X is 0.30. Momentum of X was 0.37 square over 2 times M. Okay, so this gives you M, which is 0.37 square over 2 times 0.30, which is Okay, there is another approach, my dear. You can do that way. You want to try that? Okay. Alternative approach here. First of all, using momentum is mass times velocity. Momentum was 0.37. Yes? 0.37 is neither we know mass nor we know velocity. So mass you make subject 0.37 over m is the velocity. Now go for kinetic energy. So kinetic energy is half m v square is 0.3. So you want to substitute p square, which is 0.37 over m square is 0.3. You can just simplify m by 2 times 0.37 square over m square is 0.3. M1 will be simplified. You can rearrange, it will be same answer. So I was shocked that no one tried, except 2 or 3 students, this concept, which I already told you that momentum can be written in terms of kinetic energy. So
No, sir, everyone did. this.
no,
Not
ask,
everyone,
ask.
she did it. And
No, she didn't.
Right.
Okay, next question, my dear. Determine the magnitude of momentum of block Y. So we know Thumbak is equals to Tmak. Total momentum before collision. Okay, let's take the left side as positive, right as negative. Can I take this way now? It's my choice. Yes?
Yeah, yeah.
So X, it means negative 0.37
Yeah.
and plus Y is 0.65, 0.13 plus PY. So just solve negative 0.37 plus 0.65 minus 0.13 PY, which is that was so simple. That both questions were straightforward. LOT, excellent. Very good, my dear. Next, ready? You got it? Sure? Good. Block X exerts force on block Y. Find the time. So which one you want to take, X or Y? Actually, X on Y is same as Y on X. Which one you want to take? X. So time. You know force is change in momentum over time. Which one you want to take, X or Y?
you
No, it's important. It's important.
Why?
She said again.
Yeah.
Okay. Force is 0.77. Change in momentum of 7.7. Change in momentum of X. X initially it was right side 0.37. After it is left. So change in momentum since they are in opposite direction. Yes. Final minus initial. So 0.13 minus 0.37. So 0.13 minus negative 0.37. So T is 0.5 over 7.7. Show 0.065. Sorry?
So he wants to use
What page number we are solving?
97. 97.
Page 97, right? Okay, thank you. 0.065.
See, I've been great.
Question number 5. Although we solved this question before, so let's enhance your concept. Ready? State principle of conservation of momentum for total linear momentum of an isolated system is always constant. For any isolated system, total linear momentum of system is constant. Can we balance this equation? Alpha is 4, 2. Alpha is 4, 2. So Q will be 215 minus 4, 211. 84 minus 2, 82. Okay, a nucleus P undergoes alpha decay. Before decay, the nucleus P has a speed this. After decay, nucleus Q is stationary. Find the speed of alpha. So we say Tumbud is equals to Tmad. Tumbud means total momentum before decay. Tmad, total momentum after decay. Before decay is P, right? So P, its mass is 215 U. Its speed is 3.2 into 10 power 5. After decay, Q is 0. Alpha is 4U. Speed we don't know. So, yeah, U will 215 multiply by 3.2, 10 power 5 U is 4 VU. Now, U both sides could be simplified. So, my dear, we don't have to substitute the value of U. Its value of U is given in the sheet 1.66 times 10 power negative 27 kilograms. So, 215 times 3.2 times 10 power 5 over 4 is U, which is
1.7.
you should write 2 significant actually as per given data, but it's not wrong. 1 more is fine. She said 7. Next question. Make sense? Make sense? Half of this we solved, rest half we will solve now. Ball is dropped from rest. It's your review for kinematics as well. 0.73 kg is the mass. It is dropped from rest. Initial speed, 0. Distance moved, 1.6. Acceleration, 9.81. V, we don't know. Which of the Suvat equations have these 4 letters? Excellent, my dear. So let's substitute the values. V will be square root of 0 square plus 2, 9.81 S 1.6, which is, yes, my dear, you can also solve this question using energy method. The loss in GPE is equals to gain in kinetic energy. You are right. Excellent, my dear. 5.6. But please keep in your mind that is only true if there is no air resistance or no friction. As the ball loses the contact, it rebounces. Kinetic energy is 90%. So if conserved kinetic energy is how much? 90%. So its new gain in GPE will also be what? 90%. You know GPE is mgh. M and G both are constant. So GPE is proportional to height. So if GPE is 90%, so height will also be 90%. So they say calculate the new height. So new height will be 90% of actual height, which was 1.6.
Yeah.
1.44. You can write 1.44 actually. It's a better answer than 1.4. So kinetic energy nu is 90%. So there is no air resistance. So all the kinetic will change into GPE. So GPE will also be 90%. And GPE is depending upon height. So height will also be 90%. Yani, when the ball is falling or rising up, do you think the mass will change? No. Speed of the ball as it leaves, rebouncing. So no problem. As it goes maximum height, final speed becomes 0. Acceleration of free fall, now you take negative 9.81. Initial speed is, we don't know. And height, it goes 1.44. Can I use kinematics again? V square is equals to U square plus 2AS. 0 square is equals to U square plus 2 negative 9.81 into 1.44. So it goes, you will be, after solving, 2 times 9.81 times 1.44 square root. Yeah? Which is? Dear students, use your answers to determine change in momentum. Please be careful about signs. If you took this 5.6 as positive, so then this 5.3 you will take negative. Change in momentum, M final minus initial. M was 73 grams. So 73 grams mean divide by 1000. V negative 5.3 minus U 5.6. Give me the answer with the negative sign.
Minus 2.7.
0.8. With change, I told you multiple times, don't write the sign. This sign is very important to understand the direction. So direction will be upwards, yeah? With reference to law of conservation of momentum, comment on the answer. Since total momentum of ball and, what is the other system? Steel plate. Ball and plate has to be what? Constant. I didn't say before and after. If you do it before collision, after collision, fine. So plate, so change in momentum of plate in momentum of plate must be equal and opposite to, what is the answer? 0.8 newtons. With reference to this, yani momentum of the ball change, it means there is a momentum of plate also change, so that the total momentum has to be conserved. Last question. Last question or test choice is yours.
No, last question.
Sorry. Is it gonna run?
So last question, my dear.
Sir, we continue. Yes, yes, question.
A new one?
We solved this.
We solved.
We didn't solve it.
We solved.
We did. We solved this.
Yeah, we solved it. We solved it. Question 10, we didn't solve this.
Question number 12.
We solved it.
Question 12. Define force. The rate of change in momentum of an object. You can write third law in terms of momentum or force. I will go for force. If an object A exerts force on object B, then object B exerts same type of force on object A, equal in magnitude and opposite in direction. Dear students, please pay attention. 3 marks and 4 informations. 2 objects interacting. Same kind of force, equal magnitudes, opposite direction. I want you to not miss anything from these keywords. 2 spheres approach each other along the line joining their centers as illustrated in figure 3.1. They are approaching. When they collide, the average force acting on the sphere A is FA and B is FB. They interact. You just wrote up that the forces are equal and opposite, and you wasted 20 minutes to think. Forces are equal and opposite. Time of impact is same. It is a scalar quantity. You can't write negative or positive.
Yeah, I see.
FA is equals to negative FB, equal and opposite. Time is same. Use your answers to 1 to show that the change in momentum of A. First of all, change in momentum is what? F into T. So, FA times, I'm multiplying the 2 equations. TA is equal to FB multiplied by TB. Next.
So I told you to solve
It was a test question. I didn't solve it. Dear students, what problem happened? Students like even you were not able to solve that. They ask you for the spheres in B, the variation with the time and the momentum is shown in the graph. This one is for A, and B, the half of the graph is shown. So momentum of spheres before collision is shown. Complete the graph. First of all, I told you a while ago, the collision time is same. You can take a pencil. So collision time is same for both of them. So first task was the momentum of B will continue to be same until collision starts, right? Now you need to go after collision. We say Tambak, total momentum before collision, how much? Momentum of A is positive 6. Momentum of B is negative 4. Total is plus 6 minus 4, which is 2. Which is, now Tmak, you have to fix. Please pay attention. So Tmak, total momentum of A, you need to read on the graph. How much is this? And for B is how much? Negative 4. What is their total? 6 plus negative 4, how much? Okay. Okay, after collision, all right. The momentum of A, I don't know. I plus momentum of B, I know. It should also be what? 2. It should also be 2, my dear. Momentum of A, I don't know. But momentum of B, I know it is now negative. No, this is A actually. A, I know, which is negative 0.3, yeah? Is this negative 0.3? The A, yeah? Plus B, I don't know, is equals to 2. So final momentum of B will be 2 plus 3, which is 5. take the ruler, go to the 5, draw a line after collision, and till the same point time. Now you will connect these two lines. Look, this is your final step. So this is how you do. You found the final momentum of B first using the principle of conservation of momentum.
So. So the last part.
Yeah,
Shouldn't the same grammar.
it's not same. It's not same graph. Thank you. Inshallah, the next lesson we will be starting forces, density, and pressure. Daily basis, just keep solving 10 MCQs and 2 structured questions. We'll start new topic, new books. Meanwhile, if you have questions, you can ask me that next Friday. Again, same whole dynamics and kinematics. Take care. Bye bye.